So let's get started, Pramit. Okay.
Yes, perfect.
Sure. So hi everyone, welcome to this what day? I don't remember the days also right now, but yeah, welcome to all of you to this session on practical SVM by Pramit. So over to you now, Pramit. I'll be on mute and on standby.
Perfect.
Okay.
Thank
so
you,
I think you should
Soham.
be able to share the screen.
Yes, I'll try. Perfect, Soham. Thank you. Thank you very much for the introduction. And hello, everybody. Good afternoon, good evening, depending on where you're joining from. Very happy to see all of you once again. Let me share my screen. And so is my screen visible now? Perfect. Thank you. All right. So hello, everybody, once again, and welcome to the Machine Learning Made Simple webinar series. This is still in block 4, Introduction to Support Vector Machines. Yesterday was the theory, and I will just show you a few slides from there to remind you what we're going to do, and then we'll jump into the code. So yesterday I tried to establish the conceptual and mathematical framework for SVMs and how classification and regression works with some examples. Today's session is live coding, where you're welcome to code along with me. So what I will do is I will start working through these examples, and you can code along, you can see what's going on, and depending on how much we progress, we can see whether we do everything together or we use some ready-made code as well. But I will definitely start with coding, and I invite you to join along. That's how this is going to be most beneficial for all of you. So what we're going to do is basically reconstruct this problem because some of you requested for it. This is just demonstrative and this should not take too long. So what we're going to do is we're going to basically build some points and try and, separate them with appropriate boundaries and see how that works. The aim being to finally arrive at the separator, which is optimal. So I'll reconstruct this as well, build margins around each of the lines to demonstrate, and finally come up with support vectors and an optimal separation between the two. Having done that, we will also talk about the IRIS data set, where I will classify different types of iris flowers based on certain characteristics, and we will try and make sense of what I showed you yesterday. And the last one is the representative example 3 that I showed yesterday, which is the social network ads. This is the case-specific study, and this is based on a Kaggle data set. The file has been uploaded already. What we're going to do is we're going to predict whether a user purchased a product or not based on their age and salary. So yeah, I just wanted to remind you, set the context. So let's get started. So what I will do is I will use this Google Colab to demonstrate certain things so you can code along, and at the end I will make these notebooks publicly available. So what we're going to do is reconstruct the set of points that I showed you and try and build separators. So what we're going to do is we're going to use the Scikitlearn.datasets. There are a lot of inbuilt datasets with Scikitlearn, and I'm going to use a function called make blobs. So what make blobs is basically doing is it generates points for you. So it generates an n-dimensional array and it gives you labels. So this is your X input at first, and this is your Y input. Now I don't want 3 classes. I have classes 0, 1, and 2. I want only 2 classes. So what I'm going to do here is to pass in some values. And this will help me generate the kind of data that I want. And then I can visualize this and figure out how to separate these points. And this is what I'm going for through this tutorial. So I can say two centers. As you can see, this prompts you. You can see the various options associated with the function. Random states are very important if you want to generate the same data over and over again. Otherwise, it changes with respect to every run. And then I can say that I want a standard deviation of 0.6. So now I have only two types of labels, 0 and 1, which will correspond to points of two different colors. What I can further do is differentiate between my input and output variables, and then I've got everything that I need. So let's visualize what we have so far. I want to use matplotlib, so I have to do an import statement here. So I'm importing pyplot, and this is the magic function that allows me to plot these things from within the Jupyter notebook. And what I'm going to now say is plot this numpy array, but just the first dimension against the second dimension, using the Y label to color them differently. And I can set some size. Let's see how this looks. So I've managed to generate my points. So depending on how I decide to choose my standard deviation, I can get them more separated or closer together. I will stick to a standard deviation of 0.6 so that they are clearly separated, but I can also insert different lines and demonstrate how the choice of my separator plays a role in predicting a new class. And shift to this color scheme. So now what I want to do is I want to plot a new point. And how am I going to do that? I can just say I put in an X coordinate and I put in a Y coordinate. And I say mark this point X and let's color it black. I have my point here. Not as large as I would like though, so let's make it larger. Very good. So now I have blue points, I have violet points, and I have an unlabeled point, and I now have to decide whether it belongs to this category or this category. And this is the simplest form of the classifier, and this will then be generalized to any real world data that you use. So now, please tell me, what do I need to do if I want to start separating? I have to start plotting lines, right? So what are the variables that I need in order to define a line? How can I plot my line? What are the variables that I need to define a line uniquely? Since this is a two-dimensional space, my hyperplane is going to be a line. So I would like you to tell me how I can start plotting different lines. Two variables, yes. And what are these two variables? What are the two parameters that define a line? Yes, thank you, Anvesh. So slope and intercept. So what I'm going to do now is I'm going to define some slopes and intercepts so that we can start plotting the lines and start visualizing the separators and see what works best. So how would I do this? Let me define a variable called lines underscore details. And I'm going to define this to be a list of tuple objects where the first entry can be my slope and the second entry can be my intercept. So I'll put in some numbers. In the first case, I've taken a slope of 1 and a y-intercept of 0.65. Then I can take a slope of 0.5, y-intercept 1.6, and I can take minus 0.2 and let's say 2.9 here. And this will define my line underscore details. What I'm then going to do is I have to now plot these lines to see how it separates. So I'm going to say for slope, intercept in lines, I have to now plot my line. So before I plot my line, I have to define my X and Y coordinates that lie on the line. So for X, I'm going to say, give me a couple of points. So NumPy has this really nice function called linspace, which linearly spaces out points and gives it to you based on the boundaries that you define. I will choose -1 and 3.5 with respect to my coordinates so that I get random X coordinates, and the Y coordinates are then going to be calculated based on the slope and intercept that I defined in this line underscore details. So what I'm going to do then is I'm going to say Y fit, which is the corresponding value to X fit. And that is going to be your slope into X fit plus intercept. If you have questions, if you're getting bored, please let me know in the chat box. We can adapt to your mood. I have all of this coded out just so you know. Quick note: we can also directly move to the notebook if that is easier. So please interact. If there are questions, keep telling me. What am I doing here? I'm trying to construct this line. So Y fit is then going to be my corresponding value that lies on the line. And what I need to do is plot this line. So it's going to be X fit, Y fit, and of course, I have to choose a color. Let's plot them in black right now. Sorry about that. Thank you. Yes, NumPy is not imported. I imported it now, but I still have an error. What I'm trying to do is I'm trying to take these values from lines underscore details and build my Y fit. Thank you. There we go. There we go. Thank you so much. Basically now we have lines which are separating the points perfectly. And this is what I wanted to show you from my slides. All of these lines perfectly separate my points. Depending on which I use, however, my point X is going to be classified differently. So based on the choice of line, X could be predicted to be a light blue point or a violet point. And if I go with this line here in the middle with slope corresponding to 0.5, I would classify it as light blue. Also with this line But if I choose this separator, then point X gets classified as a violet point. So what I'm now going to do is build a margin around each of these lines so that they go ahead and touch the closest points from each of the categories. So how would you do that? Any suggestions? How would you go ahead and choose the best separator for the points? So what I'm going to do is I'm going to add a third variable here, which can be my margin around each of the lines. And what I will now do is I will say margin. So now I have three variables and I have this. So what I want to do is I want to and then build margins of width like this. Does this make sense? So what this is doing now is basically building margins around each of the lines so that it goes ahead and touches the points belonging to each of the classes. So far is everything clear? Yeah, very nice. Thanks. So the aim in support vector machines now that I've defined my margin is to basically choose that separator which has the maximum margin. And now I will make my life a little easier by switching to my notebook. So this is basically what you do. And yeah, we can actually go ahead and fit the curve and then I can switch to the notebook. So what I can do is now I'll switch to Scikitlearn. Scikitlearn is Python's package for machine learning, one of the most commonly used packages for machine learning. And from here, I will import the support vector machine module, and I will import the support vector classifier from there. You need to initialize a model. And like I told you, you have to choose a kernel. In my case, what is my kernel going to be based on the discussion so far? What do you think? I'm going to go with the linear kernel because my function, yes, thank you. Because it's clear that this data is linearly separable. So I'm going to choose a linear kernel and I have to choose a margin, which is a C parameter. I discussed this yesterday. This defines soft margin, hard margin, how can points be misclassified and how wide can your margin be so as to optimize the classification. Having done this, I'm going to fit the data to the model. Yeah, so I've now fitted a support vector classifier with this C value. The Scikit-learn documentation tells you in detail what each of the parameters correspond to. The degree factor is relevant only for polynomial kernels. Otherwise, this is ignored. What kind of kernel are you using? What random state and things like this. So now that I've fitted my model, what I'm going to do is I'm going to show you how the boundary actually looks. So once you've fitted your model, you have to write a little bit of code to plot the decision boundary. I'm not going to do that here, but we can definitely talk through the code. What is generally done is you have to create a grid to evaluate the model. This is done using np.meshGrid, and then this allows you to plot your decision boundary as well as your support vectors. And then you have to plot your data and then call the decision function model. So what first gets plotted are your support vectors, which are shown here, and then your entire decision boundary. So for this data, this is going to be what the decision boundary looks like. So it's basically among these lines, but which line is answered by this question. So this code shows you that this line actually separates the data in such a way that this margin is maximized. And this basically concludes what I wanted to show you with respect to points. So basically you take points of two categories, you try and draw different lines to them to separate the points, and we see what the problem is, and then you import the data into Scikitlearn, you fit a support vector classifier on the model, and the support vector classifier clearly shows you that this line then is the optimal point, and this maximizes the margin between the 2 points. So this completes the first part of what I wanted to show you, the general concept of a support vector classifier. So now we will move on and go to the social ads data set that I wanted to talk to you about. So I'm going to be using this file. Yeah, thank you, Soham. I was just going to mention the CSV file. You need to upload the CSV file. If you're coding along with me in Google Colab, you need to upload your CSV file into this folder. If you're using a Jupyter notebook, then you have to place the CSV file either in the correct directory or put your paths correctly. So what I need to do is I need to import pandas so that I can read the data into perfect. So since this is for demonstrative purposes only, it's really simple data where you have age, estimated salary, and you have a purchased column, which can take only 2 values, which we can verify. So this is basically 0 and 1. These are the only 2 values that you've got. So what is generally done before proceeding with machine learning is to take a general look at the data and see how it looks. So I'll talk through that quickly. Pandas has a describe function, which gives you some information about the kind of data that you've got, how many points, the mean, the standard deviation in the data, percentiles, and of course the maximum values in each column. What is very relevant for our data modeling purposes is to see if we've got missing values, which is usually done using the isNull function. One can see that I've got no missing values, and so everything is fine. What we will also do is have a look at how the data is distributed. So we can use the Seaborn library to make illustrations, which clearly show me how the data is distributed. Now, what I want to figure out is what kind of separator to use. So I want to know how the data points are separated from each other. And so in order to do this, I have to actually separate the points based on their category. So once again, I'm going to look at my data frame, and I see that purchased is the column which is actually relevant. So I have to separate my points here based on whether they belong to 0 or 1 in the purchased column. So I'm going to say hue is purchased. So as we can now see, this is how it looks. So if you plot age against salary, which is shown here, the points are separated. But to get a better idea of how I can actually separate my points, let's try and do a scatter plot. There we go. So basically this shows me the salary versus the age and how the data points are categorized based on whether they've purchased or not. So orange shows me 1, which is yes, they've purchased, and one can clearly see that it might be worth looking at a linear separator, which is also what I showed you in my slides yesterday for this data. So we can try and plot a line passing through the data, which could separate the points. We can also try other kernel functions that might separate the data, and this is what we're going to do. Is there any other exploratory data analysis that you can think of or that you'd like me to do? Please let me know. Otherwise, we'll move ahead and see how we can actually fit an SVC to this data. All right, so let's look at the dimensions of our data right now. So we've got 400 rows and 3 columns. I have to construct some training data and some test data from this collection of data. Usually 70% of the data is used to train models, and the rest can then be used to test. Correlation, well, the pair plots already show you correlation. So this is how the age is distributed based on categories, because I've chosen hue as purchased. This shows you how salary fluctuates, but yeah, we can also do correlation plots between each of the categories and see what we have here. What I'm going to now do is I'm going to try and split my data and see how that works out for me. You can do this with pandas as well as Scikitlearn, but Scikitlearn very nicely allows you to split your training and testing data. The order in which you put the variables here make a difference, because this is how it splits, and this is something that I have to look up every time. And here I have to basically choose what is the ratio of my data that I'm going to use for training and what ratio am I going to use for testing. So the usual good practices associated with supervised learning in general also work for support vector machines. You have to make sure that you're cross-validating, that your data is properly distributed, that you have a reasonably decent test size and a training size so that you can validate your data properly. Once again, random state is important if you want to reproduce the same results. Oh, of course. Yeah. So basically in machine learning, I have some features which have to be passed into the model, and I have an output. So in my case here, from what I've showed you, what are my features going to be and what is my output going to be? What is my X going to be and what is my Y going to be? Please tell me. Yeah. So purchase is going to be my target exactly, whether it's 0 or 1, and the rest of my points are going to be features. So estimated salary and age, these are going to be features. Hopefully you now see why I showed you the classification of points, because these are just points. Instead of using Y and X coordinates, in this case here, estimated salary is the Y coordinate and age is the X coordinate. And all I'm really trying to do is separate these points perfectly. So my X is going to be just to be sure. Yeah, this is going to be my X. And Y is going to be my purchased column. What I will do is I will convert this now to a numpy array. And we can see how X and Y now look. So basically I've got these arrays where one of the variables is age, the other is salary, and I've got Y, which is going to be just 0 and 1. If I spell it correctly, that is, it's just going to be 0 and 1. So what now happens is I've managed to split my data. So I can now take a look at X_train. Which is a 2-dimensional array. But it has shape 300. And X_test will have, what shape will it have? What will this give me? What will be the shape of X_test? Thank you. Yes, it will be 100 into 2. So basically, I've managed to split my data into training and test data sets, and it's split in the ratio of 1:3. So 1 is your test and 3 being your training. So 75% of the data goes into my training sample. All right, now I have a question for you. Can I use my data as is and start fitting the data to a support vector classifier, or do I have to do something else? While you think, I will do a few imports. Yeah, we have to do scaling, definitely. Do we need to use gratify here? What is gratify? I don't know what gratify is. But no, I don't think so. Yes, we definitely have to scale features. I see. No, the test and train data split is already done here. And yes, for classification as well, you have to do train test split. It's extremely important. So how can you scale data? What are the options that I have? Has anybody scaled data before? Yes. So these are the two options that you've got, standard scaler and min-max scaler. What I'm going to do is I'm going to use the Scikit-learn inbuilt standard scaler to scale my data. So what I'm going to do is I'm going to take my training data, because that is all I actually have to fit into the model. The testing data should only be transformed. It shouldn't be fitted to the standard scaler. So what I should do is I should do a fit as well as a transform. Yeah, you can do this together with Scikit-learn. And I use my training data. And then what I'm going to do is and my data now gets scaled. Yeah, we could do a standardization before train test split. But what then happens is I'm cheating a little bit. My data gets biased because here, after I'm splitting, I'm fitting the scaler only to my training data. I'm only transforming it to my test. What this basically means in the case of a min-max scaler is I'm looking at my training data using the minimum and maximum values to scale my data, and I'm just applying this fit then to my test data, if that makes sense. This is how my training data now looks, and this is how my test data looks. Are there any questions? Please interact with me in the chat box if so. You don't understand how what will help. Okay. Yeah, so basically what we try to do is to reduce the spread of the data as well as homogenize any imbalances in the data. And the standard procedure to do this is scaling. There's min-max scaling, and there are other scaling methods which allow you to scale the data. And what is important is that you split the data before you scale. With X test, it should be only sc.transform. Fit underscore transform is only for the test data. Did I do that wrong? No, it looks okay. So I have to fit and transform on the training data and then only transform on the test data. So that being done, what I'm going to do is I'm going to import my support vector classifier. So now I will show you this once again to remind you that this is how my data looks. And these are the two classes of points that I want to separate. So my initial guess is going to be that a line passing through the data here would not be the worst case. And so I'm going to go ahead with a linear kernel and see what happens. Of course, nothing is set in stone. If you don't get a good score, you can always come back and try other kernels. So the support vector classifier belongs in the SVM library. Yeah, thank you. Thank you. My apologies. I'm doing live coding for the first time. So it's an experience for me as well. But hopefully you're learning something and you're enjoying it. If not, please do shout out and I can just show you the ready-made, the already written code. That's always possible. But hopefully the idea is becoming clear as we code together. So what I'm going to do is I'm going to fit the data here. So I have to use my training data and I fit my data as I did before. And the output that you see here on the screen is basically telling you how the classification has been done. So how the model has been fitted to the data. So let's do one thing. Let's take a point and try and see how the classification works. Just to make this really extreme, let me take somebody who's aged 60 and earns $130,000 estimated salary. So let's say age 60 and $130,000, and let me see how my model actually classifies this. So what I first have to do is I have to transform my data. I cannot just put in my values because the model has been trained on scale data. So I have to first transform my data. So this person is 60 years old and I said 130,000. This has to be an array. Anybody has any suggestions? What I'm trying to do is I want to use the scalar that I fitted, and that is this SC, this fitted SC, and I want to transform. So let's see how the point X train looks. Looks like this. So what if I say I want to SC transform? $60 and $130. Yeah, I tried that too, but yeah, sorry about that. Yes, indeed. Thank you. Finally. So I've managed to transform my data. And now what I want to do is I want to predict based on the classifier that I fitted. And then I want to print this prediction out. So it gives me 1, and thank God for that, because I purposely chose an example that is really skewed to see if the model is making sense or not. But hopefully you can see how this works. And if I choose something here, then it's going to give me 0. So this is how you can make a prediction for a new data point. So now what is basically left to do is look at some parameters that classify the performance of your model, whether your model is doing a good job or not. So please tell me what can be plotted to see if my model is actually making sense or not. Maybe I just got lucky with this point. Also, I chose an extreme example. So what are the usual metrics that one looks at, and what can we look at quickly to see if the model is actually doing a good job or not? So to do this, you use metrics from Scikit-learn, and you can import whatever you feel is necessary. Yes, we can look at accuracy, of course, but is accuracy the only parameter that is important, or do I have to look at other things as well? Or can I just fit an accurate model and then go home? Yes, thank you. Yeah, so there are multiple metrics that we should look at: precision, recall, true positives, false positives, true negatives, false negatives, whether my model is biased to a certain kind of data, if it's making errors with respect to only one kind of data, and things like this. So there are a number of factors which characterize model performance, and one should ideally look at each of these before validating their model. And it's not just accuracy which determines the performance of a model, but of course, accuracy is an important parameter as well. Classification report is also something that one can build directly from Scikit-learn. But what we will do now is do a confusion matrix and see how that looks. And let's also try and print out the accuracy. Well, what is missing? What do I have to do here? So I've, of course, fitted my data, but I haven't really come out with predictions. So for my testing data, I have to actually predict before I can validate them against the Y test. So what I have to do here after this line is to actually generate my predictions. So Y pred is going to be yeah, my data is already scaled, so I can just do this. So this is how my confusion matrix looks. You can read up on confusion matrices, but basically I have my true positives, false positives, my true negatives, and false negatives. So what one should ideally do is see if the data set, first of all, is balanced or not, and then see how the different predictions are being categorized on whether they are good or not. So basically, I've arrived at an accuracy score of 0.9, which is pretty good. But this is separable data and also standard representative data. It's not real life data. Even so, we've managed to actually get a good fit, and we've managed to fit our model to the data. So basically, what we can then do is plot your decision boundary. And I will not do this because this is more matplotlib and plotting than actual machine learning. But what you basically do is you have to do an inverse transform on your X-train because you want to go back to unscaled data if you're going to plot it. And then you create a grid, and then you have to build a contour, which will map your two regions based on category as red and green. And what you would then have to do is just place your points onto this contour. And as we can see, this is how the decision boundary looks. And it's very easy to identify the points which are misclassified. So these green points which are lying in red here are actually misclassified, and the red points here which are lying in the green region are also misclassified. And one can do this for the training set. Of course, it tries to find the best fit. So this is what it does. And having defined this kind of a decision boundary, you then validate the test set, which of course is a smaller set of data, because that's how I split it. And so this is how it looks. And accuracy and other parameters that you saw in the confusion matrix are all validated for the test set. But since I have the labels already, like I know the answers, I can validate my model on the test set. And now this can respond to unseen data and make predictions, which I just showed you. I can take a new point, put it in, scale it, and make predictions on the fly. So this completes the discussion on this data set. At this point, I will stop and see if there are questions or suggestions that you'd like to bring up for this discussion. What else could I do in order to classify accurately? What is the general flow? What kind of metrics can I plot? how could I do this more optimally and accurately? Any suggestions? All right. If not, we will go to the final example for today, which is the iris data set. So what I will do here is I will import Seaborn first, because you can load the iris data set directly from Seaborn. So these Python libraries come with preloaded data sets, and you can actually, we can call it df. So this directly loads the iris data set for me, and this is how it looks. So basically I've got 4 features here and 1 label. And this is basically what needs to be predicted. In this case, it's not going to be a binary classification, as we can see, because there are 3 kinds of iris flowers. And so one has to figure out how you're going to use the SVM, how a multi-type classification is done. But of course, this can be done on the fly using the SVM module built into Scikitlearn. What we then need to see is how each of these features actually affect the outcome, so that you can look at some sepal length, some sepal width, some petal length, some petal width, and then tell me that, oh, it's this species of flower that we're looking to identify. So the first thing is to see how your data frame is shaped, which I can already see here. Then I can check these things as usual. If this is interesting, what is usually crucial to do is to see if any data manipulation is required. So you see, if you have missing values in preloaded data sets, test data sets, there's never any missing values. So but real life data is usually not like this, and you have to check what's actually going on. But for our purpose, what we're going to do is we are going to see how the different variables talk to each other to figure out what it is that I actually have to do. So what I will do is I will say, and what is my hue going to be in this case? Yes, thank you. I want to see how the different species vary from each other. So my hue is going to be species. There we go. So the pair plot functionality of Seaborn actually gives you a bird's eye view of your data very nicely. And this is basically what I showed you in my presentation yesterday. So you can always take 2 parameters at a time and see how they vary with each other and whether you can separate them. So basically, this is sepal length. And if you plot this against sepal length, of course, you're going to get a distribution. But if you plot it against the width or the petal length, you can see how the variables actually correlate with each other and figure out how you want to actually define your decision boundary. Of course, here I have 4 variables. So it's very hard to visualize it in a 2-dimensional space, but I can choose any 2 to also give you the general idea of how the points are spread out, which is what the pair plot is showing you. So for instance, here I can draw a line here which would separate these categories and then think of a boundary here. Or if I take the case that I took yesterday, which was, let's look at my slides, which was sepal width and sepal length, then I'm going to look at this. So sepal width and sepal length. So one can understand why a boundary like this would actually make sense. And I can have a linear separator here and a linear separator here, or I can have polynomial functions, which is what I was trying to show you yesterday. So what I need to do is I need to train. Yes, it does sound like a Netflix series. I can use my data frame directly, but what I'm going to do is I'm going to just drop the species column. And then take the species column and put that as my labeled output. Of course, you can play around, you can remove one type, make it a binary classifier, take any two variables, but I'm not going to do that. I'm going to fit a classifier on all the data that we have, because this is a toy model anyway, and it's done, and it's been done extensively in all forms. So you can pretty much look up anything that you want to. So I will go ahead and fit the classifier for instructive purposes on the entire data. So once again, I need to initialize my support vector classifier. This is not going to work because I have to first import my model. So what I need to do first, what do I need to do to get this to work? Tell me, I'm not going to code alone. You have to help me along. What do I need to do? Yeah. Also, yeah, thank you. So of course, I have to define my training data. I have to define my testing data. I have to define how I'm going to split my data. And I have to also scale the data. So we did 25% last time. Let's go with 30% now. This would work, but ideally I should be scaling my data. So let's go ahead and do that. Thank you for the questions. Yes, we can definitely put a random state. Hopefully it is now clear why we need a random state, because if I want to rerun this every time, for those of you who have some experience with fitting data and using machine learning algorithms, you will know that you'll get slightly different results each time you run it. And if you want to reproduce results exactly, then it's advisable to use the same random state. And yes, you're right. Thank you for that question. It is possible to proceed here without scaling the data, because the data is spread out, and there are no potentially overlapping points that will seriously interfere with the algorithm. But it is still generally good practice to scale. So I will go ahead and scale the data right now. So what do I need to do to scale? I have to import my standard scaler. No, I'm not doing this right. I should be doing this after defining my. Sorry about that. Hopefully the idea is clear. I'm going to fit and transform on my training data and then only transform on my testing data. And once this is done, I'm going to fit my model strain Y train. Hopefully that works. So then what we will do is we will make some predictions. We will do svc underscore model dot predict. So somebody said, somebody suggested classification report, right? So let's build a classification report for this example so that we explore that as well. I think that is Scikitlearn metrics 2, if I'm not mistaken. Yes, it is. And then we'll do a confusion matrix as well. So to build my classification underscore report, I need Y true and Y pred. So Y true is going to be, what is Y true going to be for me? Y test, yes, thank you. That is my truth. And what I've predicted here is called predictions. I will print it out. Yeah, so it looks really good. A precision of 1 for these two types of flowers. There's one misclassified point which I saw earlier as well when I was trying to fit the classifier. I don't know why that's happening, but in general you have really good metrics which you usually do for these kind of problems. The last thing that I want to show you before I leave you is what happens if I want to change my parameters. So what are the parameters that I could actually change quite easily in my support vector classifier? Please tell me and we can try changing some of those parameters. So I will define this as a dictionary and put in different values as lists and see what output I get. Yes, we can change the kernel and we can change C. So let's try changing C. So let's try changing the margin and let's try changing something to do with the kernel. So we can try changing gamma as well. So gamma will be for the kernel and C will be for the margin. And these are the two parameters that I can change most easily. So let's define a list and let's go for 0 0.1, 1, 10, 100. So let's go in multiples of 10. And similarly, I can define my gamma values in this way. So what I will do is I'll go with 1, I'll go with and I can maybe go with so what am I going to do now? I'm going to do what is known as a grid search. So I have to define my grid and then except that I have to first import the grid search functionality from Scikitlearn. Okay. Let's print out some stuff. And then I'm going to, of course, fit my data. So basically what this is doing is it's trying out all combinations, all permutations and combinations of my C and gamma value. And it basically optimizes this for me. And this is what is known as a grid search. So I just wanted to introduce you to the concept of a grid search. So I can sort of sample all my parameters and figure out what works best for this data set. And usually what is done is you take an upper limit and a lower limit and an upper limit and a small margin, and you keep iterating over various values until you've sampled the entire grid space. And then we can make some grid predictions as well. So here I'm going to be using Xtest. Then we can go ahead and print our confusion matrix, or we can actually print our classification report, because that will give you everything anyway. And now my predictions are going to be grid predictions. Then there we go. So not much has changed, unfortunately. This point is still misclassified, and so I have a precision of 92% for this. But in general, this is how grid search is done. The only thing that I learned from this is my point was not misclassified because of the wrong choice of the C and the gamma parameters, which is also a finding in itself. And with this, I've basically gone through the IRIS data set and talked about how we can fit a support vector classifier to this data. And so if I now return to my slide here, hopefully this now makes sense. So this is how you get your boundaries, and then you can fit your data, and then given certain inputs for width, length, sepal width, petal width, and other parameters, you can figure out which class it actually belongs to. So with this, I'm actually at the end of the session for today. Thank you very much for joining. We talked through the IRIS dataset, we talked through the social network ads, and I also gave you an illustrative example of how you can just take random points and separate them by building a hyperplane. I will now stop sharing my screen and take questions from you if there are any. Please interact. I'd be happy to see what you think, and thank you. Thank you very much.
Thank you so much, Pramod. By the way, will you be sharing this the files on Slack or maybe on email to me, so that I can maybe share it on the group?
Yeah, Slack? Sure, definitely. I can. I mean, the notebooks that we now built, that we work through, I'll share those directly.
Sure, definitely.
So people can just play with it. Yes, indeed.
Yeah. So you guys have, I mean, the attendees and participants, all of you have any kind of doubt, we are already up for it. So
yes, absolutely. Please bring in the questions. So once again, apologies for the typos and things like that, but I actually managed to show everything that I wanted. So I'm happy. Hopefully you got the general idea. And yeah, please come forward with some questions.
I mean, it was very excellent, actually. Even I didn't, know about the search grid and all much. So I did learn from it also. Thank you.
Happy to hear.
Yeah, please bring all the questions. We are up for it, definitely. I think your session is so wonderful that not many of them will have some doubt. I think so. But yeah, please go ahead. You can definitely ask your questions.
Thank you very much. You people are very kind. Thank you.
Srishti, I believe we are going to launch, or you can say we are going to conduct one more such of the sessions in coming months, or I think by November, somewhere during Diwali, or after that, or maybe before that. That will be based on the end-to-end projects that we are planning. So that is in the planning as of now. So we'll be announcing that I think by on the end date. So that is something good news for you also. Thank you, Anvesh. Thank you, Anvesh, for wonderful words. Thank you, Satish. Thank you, Evar.
Thank you, all of you. Any questions, any suggestions about the algorithms, anything else that we could have done that we should have talked about? Please bring it up for discussion, and I'm happy to listen to your thoughts.
Definitely. Pramit, could you share your GitHub ID over here? I think that should work out.
Yes, absolutely.
If you have already uploaded this on GitHub.
No, this I haven't, but I will upload it. So I'll share my GitHub ID now, and then I will also upload it. Yeah, that is actually easier. Then people can just directly.
Yeah, definitely. When I'm looking out at it. So guys, do ask us any questions if you have. We are up for next 5-10 minutes.
So you can find me here on GitHub or search for me by name. It's just first name space last name. You can find me easily, and yeah.
Okay, I think you shared it with just us. I'll reshare it on everyone.
Thank you.
Welcome. No worries. So yeah, do follow him over there. And there are a lot of other projects that he's doing up.
Yes, there are a lot of projects in the pipeline which will definitely become public soon. So yeah, and thank you very much for that compliment.
Yeah.
And I will also upload these three notebooks, and feel free to extend, feel free to experiment, and
yeah. Maybe I think what you can do, Pramit, you can make up the branches for this and put up as day 5, day 6, whatever day is today. I don't even remember, but yeah. You can upload that as such day name, and I'll share this on the Slack directly.
Perfect. I'll do that right away.
Yeah. Thank you so much.
Okay, I don't think there are any questions.
Yeah, definitely. I think no one has such a good questions as of now, because your sessions is totally awesome.
Thank you. Or people are just tired after so much programming. Yeah.
Maybe that could be a thing. But yeah. I think we will be up for next 5 minutes more. If you have any kind of doubts with regards to the sessions, with regard to SVM, with regards to any other data set that you are having any issue with, we are up for that questions also. Or if you have any other doubts with regards to the tasks that are going on, even that is fine. That's great, Pranita. During this, any scenarios where SVM has a better handover?
Yeah, thank you for that question. Yes, that's a very important aspect of dealing with SVMs. I think SVM has a huge advantage when the data set is not easy to interpret. So you can't look at the data and immediately figure out, oh, this parameter might be important, that parameter might be important, and things like that. SVMs are very useful because it's a purely geometrical approach to the problem, which is what I was trying to explain with the points and things like that. It's entirely geometrical. And so this can be both an advantage and a disadvantage. It's not explainable, but at the same time, if you can't actually explain your data, it's really useful to work with SVMs. So when you can actually geometrically put your points in a way that they can be separated, SVMs have a huge advantage. And they're very robust algorithms, sound mathematics. So once you actually use SVMs and fit it to the data properly, predictions are very accurate.
Yeah, I think lot of people nowadays, they are utilizing the thing, what do you call, pipelines, ML pipelines to apply all did we lose him?
No, I'm here.
Yeah, now I can hear you. I think my connection is not proper. Yeah, do let me know. So is that correct? That
yes, yes, absolutely, absolutely. People do use pipelines, and I thought I'll show that as well, but then I thought it'll be too much, and I'll just stick to
the pipeline is actually a very big thing.
Pipelines are very big.
I think we can cover.
Yeah, absolutely. They're very involved topics. Yeah.
Or some other companies like even Haptic, such as I mean, my friends are working on those company. Okay, yeah. So my friends are working in those companies. So they suggested that MLOps is one of the most utilized area right now. And what
Soham told me earlier today that there are some problems with the power at his place. So maybe that's why it keeps getting disconnected.
Yeah, I think so.
But yes, Soham, you're absolutely right. I mean, MLOps is big and pipelines are very, very popular in the industry now. Indeed, indeed.
Yeah, definitely we'll look after that maybe in the next event.
Yeah, that would be great.
Sure. So guys, if there is no question, we can definitely take your leave for today. And have a great weekend today. I mean, it's already ending up in India. But yeah, for other people, have a great weekend. And we'll see you tomorrow for our session on logistic regression that will be taken up by Namita. So I'll definitely share the data sets and all prior to this and on the Slack channel as well. Okay. Thank you everyone. Thank you for joining.
Yeah.
Thank you,
Pramit. Bye-bye.
Thank you, Ilya, for hosting it out. Have a great day. Bye-bye.